Everybody sees my screen, correct?
Yep.
Yes.
Alrighty. I'll call the meeting to order. And if the other chapter chairs want to do a business meeting after chapter 22s, they're welcome to just speak up. So we'll start the meeting with minutes from our January meeting. Benny?
Yes. Okay. Minutes from the January meeting held January 20th, 2021, virtual via Zoom. Meeting was called to order at 7:07 by Tom. A big thanks to Scott Feibush for this month's presentation. The minutes of the December meeting were read. A motion to approve by Jim Peck, seconded by Gary Hartman. Motion passed. Treasurer's report. No checks were written, no income except for interest. We have reached the end of the road in finally switching credit card processors. Yay for that. Taxes are still in progress. Since we are on extension, there would be no penalties. A motion to approve by Tom McNichol, seconded by Vinnie. Motion passed. Frequency coordination, nothing to report. Certification, nothing to report. Brief discussion on Syracuse radio history and the AM stereo, which was developed at GE, or FM stereo, which was developed at GE, ensued. There was no old business. Under new business, introduced new SBE Executive Director Jim Ragsdale, who joined the meeting. Jim made some brief comments thanking the chapter for still meeting in some fashion, this fashion. Renewals are coming soon. Look for them. I've received mine. The Expo 21 has been postponed. Several challenges are still preventing a successful expo. Possible dates for 2022 include September 28th through the 29th and October 11th through the 12th. The next meeting will be on February 17th with, I can't remember how it was pronounced, so I'm not going to try it. A motion to adjourn by Vinnie, seconded by Jim Peck. Motion passed. The program for the evening was Tower Sites I Have Known and Photographed by Scott Feibush. Any additions, changes, comments, quotes, whatever?
We'd like to make a motion to accept the minutes.
I move to approve.
Chapter 22 member,
Jim Peck.
Jim Peck. Who would like to second that?
I'll second it.
State your name. Was Pete? Okay, Pete Peters. All in favor, chapter 22 members, say aye.
Aye.
Opposed, say no. Or nay. Okay, let's move on to treasurer's report. Gary?
Okay, the woman who does our taxes tells me they are done. At this point in time, I have not received them. So I will follow up on that. Otherwise, we are solvent.
I take it I will have to sign the taxes. I usually do.
I'm not sure on that. I think possibly on the state, but I don't think so on the federal. But,
All right. Well, if you need my signature, you can mail them to me, or I can meet you somewhere. Just
Yep.
let me know.
Right.
I don't think I've driven on the thruway since last March. So. Probably nice to get away for a day. Okay. Who would like to make the motion to accept the treasurer's report?
So moved.
Chapter 22 member. Who's that?
Me.
Oh, Vinnie. Okay. Who would like to second that?
I'll second it.
Pete Peters again. All in favor, say aye.
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 Opposed, say nay. Accepted. Moving on, frequency coordination and certification reports. Gary?
We received a frequency coordination request or notification from the U.S. Air Force that they plan to be doing some testing around Rome, Whitesboro, that general area.
Oh.
And that's basically it.
Is there frequencies or
Broadcast
anything?
interest?
Say again?
Gary, any frequencies of broadcast interest in the testing, or they just said we're going to be lighting up the spectrum? I hope you don't mind.
Well, I can't get to it right at the moment. My recollection is that they were basically lower frequencies, 900 megahertz and that vicinity. But I can
I've
find the
done that
document.
before in that frequency. Yeah.
You know, I can find the document and
Yeah.
email it to you if you want the specific.
Just general curiosity. ISM is unlicensed anyway, so it's.
Okay. Nothing on certification, Gary?
Nothing on certification.
Okay. Does anybody have any other old business they'd like to discuss?
Nope.
If not, we'll move on to notes that Jim Ragsdale sent over. He's a little more elaborate than John Porter used to be. He sent a full page of notes. I'm not going to read through all of these. I put it up there. You can take a look at it. I'll give you a minute. Step to the next slide. Basically, it's I think we had this up last time, technical professional training program that they're offering at National now. Way to train new and entry-level technical professionals at TV and radio stations. If you're interested in getting involved with that, get a hold of Kathy over at the national office. It's crose@sbe.org. Membership renewal. If you didn't get your renewal in the mail, then contact national office. You have the option of upgrading to Member Plus, or if you're a Member Plus already and you don't want to be Member Plus anymore, you can downgrade to be a regular member. But get that in by April. Next webinar coming up is February 25th, and that's the next in the series of IP networking with Wayne Pantacina, our national president. And it's part two, I believe. So it says, doesn't say. I think it's yeah, it is part two. Part three is coming up next month, and that will be more on IP, focus on everything. Layer 3 will be next month. Certification exam dates with local chapters. There's the next available dates and the application deadlines. And he says if you want to see the financial statement, you can call him, and there's his phone number. If anybody wants that afterwards, let me know. We'll talk about the expo quickly. The Chapter 22 officers decided to cancel the expo for 2021. We mentioned that last time around. Holiday Inn has agreed to return half of our deposit, so we will get $500 back. Our new rep is Amanda Joss. Kate Berry left. She went to, she's just taking another opportunity somewhere else. She didn't say where, but I did talk to Amanda today. She said they're in the process of writing that check, and you'll get that in the mail, Gary, the $500 credit, a refund of half of our deposit. For 2022, she's got it penciled in for us Wednesday, September 28th and Thursday, September 29th. I will talk to Jim Ragsdale hopefully tomorrow. I'll give him a call and make sure that SBE National is still on board with coming in 2022 if those dates appear to be okay. Of course, we never know this far out who's going to shift shows around, and like NAB did this year, they shifted to fall. We don't know what's going to happen in 2022. I'm assuming things will be close to normal then, but we don't know. But you know, we'll work with these dates for now, and if we have to change down the road, we will. We do have a few exhibitors that paid in 2020. I know I said last time that I'll get notices out to them, let them know they can get a refund or apply their payment to 2022. I want to make sure we've got these dates confirmed before I do that. And I'll work with Gary on who has to get those letters. Any questions about the expo? Does anybody have any other new business they'd like to discuss?
Have some local interest things, if you want to classify that here.
Okay. Go
WCNY
ahead.
FM went on the air from the new antenna on the WSTM tower today.
Oh,
And WSTM is going to convert to ATSC 3.0 on March 11th, and Buffalo is going to convert March 18th. So
wow.
those are the two conversion dates for the two markets. So
Okay. So
Tom,
where will they be? Where will the ATSC1 channels be?
channel 3 will be the ATSC 3 host. Channels 5 and
Okay.
9 will be the ATSC 1 lighthouse stations. So NBC will end
Fox.
up on WTVH. The CW will end up on channel 9. I cannot remember at this particular moment where Comet's going to be. It might be on TVH as well.
Hey, Vinny, can you give me those dates again?
Syracuse is March 11th. Buffalo is March 18th. I know they're working on Rochester. It's in there somewhere. So I don't know when.
Okay.
So Vinny, are these additional sub-channels on SYR and TVH, or are they
Yes, they are.
additional?
Additional sub channels.
Okay.
Interesting.
Or
in other words,
Comet is on TVH. Yes. Kevin apologizes. He doesn't have a microphone tonight, so he's interacting with me via text. Comet will be on TVH as well, along with Charge and TBD.
Wow.
Okay.
New encoders.
We have them. They're in-house.
Harmonic?
ATEM.
Okay.
Tom, if you want to if you want to unshare your screen for a second, I can show you. I can show you the coordination request. The test frequencies are listed as 2110 to 2770. That is 902 to 935. I don't frankly understand that.
I think they're saying 2110 to 27770 megahertz, and that's just an example of 902 to 935 to fill in.
Yeah, I think I think you're right.
Right.
So
2 gig,
777.
huh?
That's a big range.
Yeah.
yeah, sure is.
So watch out for your STLs.
Yeah.
Yep.
Okay. I don't know who to call if I'm problems. Okay.
So more on the ATSC 3 conversion. Channel 9's gotten new harmonic encoders for this. And that might be spread spectrum, the Air Force thing. Who knows?
Oh, one more piece of new business. Vinny and I have been talking about doing something for Roy Taylor to remember him. I know in the past, Chapter 22 members, we've bought a piece of glass for Coleman's. Roy wasn't really into the Coleman's thing, going there. He was more 10-pin alley in, is it Canastota?
Chittenango.
So we're talking about Chittenango, that's right. We were talking about getting a plaque to hang there. And I know Dana's on the meeting tonight, and Dana's going to look into who to contact over there. And if we do that, then, and they're okay with us doing that, we'll put together a group. Anybody that wants to attend, wait till times get a little bit better and a little COVID safer, and maybe ask his daughter, her and family members would like to attend, and do a little presentation of the plaque that they can hang on the wall there to remember Roy Taylor. If anybody has any other ideas, go ahead and bring them up. We're open to listening to any ideas you have. No? Okay. Does anybody else have something they'd like to discuss?
I have a question. I saw the SBE, this is Craig. I saw SBE is doing some presentation for the new revision H of the tower codes. That's tomorrow. Is that something that is in effect that we have to do now when we're studying towers, or are we still able to do G? Anybody know?
I don't know.
Okay, thank you.
Don't know.
Have to look into that. Okay. Who would like to make a motion to close the Chapter 22 business meeting?
So moved.
Jim Peck,
Gary,
second.
would you like to second that? Jim Peck, second. All in favor, aye? Aye.
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 Oppose? Oppose, say nay. Okay, and thank everybody for coming out tonight. Do any of the other chapter chairs want to do a quick business meeting, or you good? I don't know who else is on. I know Greg is on. Nolan
Tom,
is.
thank you. I'm good, Tom. Thanks for the opportunity.
Okay. Yep. You guys are welcome to do that anytime you want to in our, in our meetings here. Okay, with that being said, we'll move on to our presentation. Jay Dankin from Egolgi will be presenting tonight. And Jay, thank you for coming out with us tonight and talking to us about ATSC3 or ATSC transmission. And
Well,
I will
that's
unshare my screen and you'll be able to share.
okay. Let me jump up here. Actually, I'm going to be talking about a couple different things. ATSC3 being one of them. Let's see. Can you guys see that now?
Yep.
Yes.
Technology is amazing. I wish I had talked to some of you guys a little bit earlier with the stations going to ATS 3.0, because we do have a really good solution. But we'll get to that. So I'm going to talk a little bit about Egolgi and some technologies that we support. Just to give you an idea of my background, I've been in the broadcast compression and decompression since the very early days of MPEG-1. For those of you that know what a C-Cube CL450 chip is, I had a product that utilized that back in, I'd say the early 90s, something like that. There was the old Video Blaster chip was one of them. They used that chip. But all right, so, but Egolgi is a technology company. We've been around 12 years. Probably the best little technology company that you don't know of. So, we talk about a lot of things, but our focus is on broadcast distribution, both over the air and obviously today, internet. A lot of that has to do with transcoding, OTT, and ATSC also. ATSC 3.0 was designed actually with to be a hybrid system where you get both over-the-air broadcast as well as over the internet. We've been in that market. We've got a lot of products. We've built products for a lot of other people as well. As I mentioned, we were founded in 2008. Our corporate is based actually in the Princeton area with an R&D lab just outside of Chicago. One of the things that's very unique about us is that we can do special features for people. We're not afraid of doing that. We're not a one-size-fits-all type shop. Everything is software-based. We do run Linux as an operating system. We have our own codecs as well, so we're not relying on a third party for the actual compression algorithms and everything associated with that, which means we can tweak them for particular applications and particular needs. We also do file and stream processing simultaneously in the same box, which is something else which is a little bit unique. And I'm trying not to make this too much of a sales pitch. I want to get into some technology. In a video distribution system, it's just a block diagram, a very basic one. You've got obviously your sources coming in. You ingest them, process them. Some is going to be stored, some will be streamed, and then it goes out into various different applications, whether it's OTT as a internet broadcast IP, or going in over the air, ATSC 1 or ATSC 3.0 now, or over satellite as well. These are just some of the products we do. I'll skip over that. I want to talk a little bit about the differences in some of the two codecs, HEVC, also known as H.265, and MPEG-4 or MPEG-4 ABC, known as H.264. H.264, I said, is also known as MPEG-4. Actually, technically, it's Part 10 Advanced Video Codec. We generally refer to it as just MPEG-4. It is block-oriented. It's a much more efficient codec than what it's basically replaced, which is MPEG-2. You see it in a lot of different applications, things like Blu-rays over the internet, HDTV broadcasts. It's used a lot for backhaul. I used to do a lot of backhauling of sports for some of the networks. And it was all MPEG-4 over satellite, or now it's over fiber. More recently, when I say more recent, it's been about 10 years actually, H.265, or it's known as HEVC, which is an acronym for High Efficiency Video Coding, is the new standard, which is also the standard in ATSC 3.0. When you compare it, there are some significant differences. The biggest one is that HEVC is significantly more efficient than MPEG-4. It was based on the same technology, it's block oriented, but some of the differences in MPEG-4, it's a 16 by 16 pixel matrix or pixel block. In HEVC, it's a 64 pixel by 64 pixel block. MPEG-4 does support 4K and even 8K, but it's really not efficient enough for most applications unless you've got some really big pipes or you have a lot of file storage. As you notice, I've kind of neglected MPEG-2 because it's really old technology. It's being phased out in most broadcast applications. Obviously, ATSC 1.0 is MPEG-2, but beyond that, you see very, very little usage of MPEG-2 anymore. But I said with HEVC, it was designed for higher resolutions in mind, things like 4K and 8K. Essentially, when you look at the two of them together, 4 versus HEVC, it's about half the bandwidth for HEVC or half the file size for the same quality. Or you can go higher quality and have the same bandwidth. So HEVC at the same bandwidth as MPEG-4 is going to give you significantly better quality. I'm skipping through some of this. I think some of you guys are probably reasonably familiar with the differences. But the issues come in when you're going over networks. It's not so much with broadcast, even though that is a limitation. But when you get into the internet or fixed networks, any type of IP distribution in different areas, bandwidth becomes very, very important. But the key to it is it's better quality at a lower bit rate. To give you some example, this is using 18 megabits as the average internet speed. It's probably a little bit higher than that now. But if a lot of people are on cable modems, where you might have 100 megabit or 200 megabit feed from your cable modem, in reality, you're not getting that type of bandwidth. Or if you're like me and you've got 5 televisions in your house and they're all streaming over a Roku stick, any one of them is not going to get much more than about 10, 20 megabits. But MPEG-4 to get for a 4K broadcast is roughly 32 megabits, and it's less than half of that for HEVC. So you can see the efficiency there. I'm going to talk a little bit about transcoding and what that does and why we use it and why it's important. Some people refer to transcoding as video encoding. It is a form of encoding as well, but generally with transcoding means you're transforming your content in one or more of the 3 elements, which would be the file format, which could be a file that you're recording to a disk, or it could be something you're streaming, whether it's different like MPEG-2 to MPEG-4, MPEG-4 to HEVC, the video, which would be the resolution and bitrate of the video, and of course the audio. And audio, again, you're generally changing bitrate. You may be changing audio codecs as well. So it refers to a lot of different things. In the older days, a couple of years ago, it was all done in ASICs, in fixed silicon. These days, most transcoding, or at least most advanced transcoding, is done at the processor level, whether it's in a CPU, multiple Xeon processors, for instance, or GPUs, graphic processing unit. So we've done a lot. We're doing a lot more in software now than what we used to do in hardware. It gives you a lot more flexibility as well. So in transcoding, as I mentioned, there's really 3 different things. You have transcoding, which is changing your content, changing the codec. You may be adding things like watermarks, logos, other things to the video in that process. But essentially, you're decompressing the video and recompressing the video at a different bit rate and a different resolution, or just a different source. You can also just transrate, which is just simply changing the bit rate. You're keeping the resolution the same. You're just lowering the bit rate to fit into the pipe better. And then transizing would be changing the resolution without changing the bit rate. They're all interrelated and they all impact each other. And then when we get into things like OTT, over the top transmissions, things like HLS, MPEG-dash, you'll see why that's important. Something else that comes up occasionally is another term called transmuxing. And that's more where you're changing the container that the video is in. Whether it's a straight MPEG transport stream, you're converting it to HLS or MPEG-dash or smooth streaming or any of the different formats that are out there. I'll be transrating. So transrating is part of transcoding often, and when we're converting into over-the-top streams, OTT streams, transrating is part of it, but it is a separate process. So why do we want to transcode? So I mentioned changing your video formats to fit into different applications for different uses. But the main reason really is quality of experience, is maximizing what the viewer sees to give them the best experience, the best quality at whatever pipe they have available. However they can get that content, you want to maximize that quality. You can also transcode, I said, into files, and there you're sometimes doing it just to reduce file size. A lot of people are starting to store stuff up in the cloud now. You pay for that storage. I mean, storage is not finite, is finite, I should say. It's not infinite. So, and you're paying for, a lot of times in cloud storage, you're paying for the transport more than you're paying for the storage itself. So bit rates become very important and file sizes become very important. And I said there's other reasons. You can do some editing, clipping, trimming, maybe add different languages to it, adding captioning and things like that. It is vital for streaming. We couldn't be streaming without having transcoding, which allows you to get to a much broader audience. Broader audience is more eyeballs. From a revenue standpoint, eyeballs equal dollars. As I mentioned, the quality is important, and then different formats. Some of this is a little repetitive. So what is OTT? Over the top is basically broadcast over the internet, bypassing normal over-the-air broadcast. A lot of this now is hybrid, and things like ATSC 3.0 are hybrid systems. They combine both over-the-top and traditional broadcast technologies. It's growing very rapidly. A lot of, if any of you use things like a Roku stick or Apple TV, that's all over-the-top broadcast, or what we would call over-the-top. It's all streaming technology. Some of the things that it lets you do is you're not limited as much with OTT as you are with a traditional linear broadcast, in that you can choose your packages, choose what channels you want to see. You don't have to buy packages. It's a little more cost effective. It's by nature kind of an on-demand system as well. There is, quote, linear broadcasting on OTT, where you have like your, say your local channels, for instance, or you're going to be watching them live. But much of what people watch over the top is coming off of a server somewhere and then being packaged for them. It allows broadcasters, like I said, more reach. So you can get into markets that you weren't in before, and other revenue streams because of that. It's also not, what's the right word? I guess the hardware that you use, it's not dependent on a specific hardware. If you're a traditional, say, cable company, you provide the set-top boxes to your customers. If you're a DirecTV or Dish Network, you provide specific set-top boxes. With OTT, you're not limited. You can choose the device that you want to use as your client. It can be a web browser, it can be a smartphone, it can be something like a Roku stick, an Apple TV, an Amazon Fire Stick. I mean, the list goes on. You see these days Android TV. They're little set-top boxes that are Android boxes. All of that is for OTT programming for delivery via the internet, which by nature is a non-deterministic network. It's given a lot of opportunities for broadcasters, and they're embracing it. Another thing which you can see with OTT, I know ESPN has done it, iStream Planet has done it with some sports, is it gives the viewer the ability to switch their own show, where they can see multiple cameras on their screen and select what they want as their main view. It's something you couldn't do with a traditional over-the-air broadcast. So you get to choose what you want to do, when you want to see it, and how you want to see it. It incorporates a lot of new technologies as well. Adaptive bitrate is something that's important. In OTT, one of the issues that you have, being the internet non-deterministic, so you don't know how much bandwidth you have at any time, is what OTT does is it takes your content and creates different profiles. Each profile is a specific resolution and bit rate. It then sends that data out in chunks. Those chunks can be as little as a second or two, or it can be as long as 30, 40 seconds. Generally, there are 5 to 10 second chunks. And what the client does is says, it takes the best one that it can. So it'll always look for the highest profile that it can get consistently. So the faster your link, the higher the resolution, the higher the bit rate. But if your link goes down in speed, it will automatically switch to a lower profile or a lower resolution or just a lower bit rate. It could be the same resolution. The quality is going to drop. But that's an automatic function, so it always maximizes the best image it can give you at any given bit rate. As I mentioned, it's one packet at a time, and you're not locked into hardware. Some of this, I apologize, some of these got repetitive slides. But one thing to bear in mind about OTT is it's not about the content. It's not what you're providing the audience, but it's how you're providing it. It's the technology that's involved in getting it to your end user. And it does lend itself to VOD, video on demand, very well. Video on demand is sent as an OTT stream, but they are different, a little bit different. You're taking your files and getting it that way. You're selecting what you want from a server somewhere. On the downside, there is a little bit of latency involved in OTT. When you switch channels, it takes a little bit. It has to synchronize to the server. It sends a message, says, okay, this is what I can get. There's also some downsides in OTT in that it does use up a lot of bandwidth. An OTT stream is all unicast. So when your particular client, when you select a channel, that is a unique stream coming to you. But in that stream, you may be looking at, say, for instance, a 10 megabit 1080p stream. But what you're also getting is a 5 megabit 720p stream. You're getting a 2 megabit 640 stream. You're getting a half megabit at 540. You're getting 256K at 320. You're getting a variety. So that 10 megabits is actually, say 20 megabits being sent to you. And that's where we'll get into some technologies which can save money, and bandwidth is expensive. So what we've developed is a product we call iGoCast, which is a OTT head-end in a box. And it's pretty much, it's one box which has everything in it you need that you plug into the internet. It can be subscription-based, it can be free-based. It's all how you want to do it. The integration is there. It's not designed, this product is not designed, for instance, for going to hundreds of thousands of subscribers. It's not designed for that. You would use, someone like Amazon Web Services or a large OTT provider, or you have built it into your own head end, is what a lot of people do. But for not what I would call non-traditional broadcast, private networks, if you're working with distance learning, things like that, where your subscribers are in the hundreds or maybe 1,000 or 2,000, this is a great way to go because it's all integrated in one box together, has all the different components that you need. In that, there's a transcoder, so you're generating the streams. We then, as we've generated all our different profiles in OTT, you need to package them together and put them into, typically these days, an HLS stream. From there, it's now one stream, one MPEG transport stream that's going to a server, which is the origin server, which now streams it out and manages that. You've got some software thrown in there in the middle, which manages some of that, gives you things like user guides. You have your client application that you're going to use. If you're using something that's subscription-based, you have to have a portal in there for taking payments. It could be something that's stored. It could be you put in a credit card, however you want to do it. For subscriptions, obviously you want to get the metrics and the analytics from it. Who was watching what when? So you now know if you're advertising on this, if you're selling advertising, that's critical information. Your administration portal, encryption is also, it's a little less important encryption on an OTT stream, only because it's going to a specific person. So you're not sharing that stream with other people. And then things such as DVRs or PVRs, personal video recorders, where you can store it and play it back at your convenience later. And then, of course, ad insertion and things like that. Typical head end for something like this, again, you'd have on the top, you bring in your encoding, you transcode it, you package it, you add in your encryption, your stream server, things like that, and then out over an OTT network, over an IP network, out to that, or it could be transmitted as well for things like ATSC 3.0 applications, where you're going over the air and you're getting the data that way. Our particular solution, we have a 2U form factor that has a transcoder built in, or if you have your own transcoders already, we can interface with those. It's 1U, but we do 15 SD or 6 HD channels in this box. Of course, it's got redundant power supplies and all the other stuff that goes with it. What I really want to tell you about, this is something which is groundbreaking. It's a product we call Blazar, which is a ultra-fast transcode platform. Is really next generation, and what it gives you is transcoding on demand in 200 milliseconds or less. A traditional transcode can take up to 2 or 3 seconds for it to do multipass transcoding. Our secret sauce, so to speak, in this product allows it to transcode very quickly. So it gives you some unique capabilities, unique features. If you look at a block diagram, you have your live streams or files coming in that you've stored on your servers into an IP. Everything here is IP based internally. When we say master and worker 1 and 2, think of those workers as transcode engines. So there's multiple transcode engines operating simultaneously that you're developing these. As someone asks for a stream, it generates the stream. It then goes back out and it goes into your packager and everything else. So it serves a couple different functions. One of them, like I said, is to save bandwidth. What you find is that the majority of people are using the highest profile. So they're using that, as I mentioned, that 10 megabit profile. That's what most people are viewing. So all the rest of that is wasted bandwidth that costs money. It also is storage on your servers. You do have to store those streams as you're transcoding. You're actually storing the file. It's kind of a FIFO, but you're still storing that information. So just-in-time transcoding is very interesting to a lot of people because of the savings that it's going to give you. It is scalable, so you can scale this to however big you want. The way we designed, at least the first version of this, it supports transcoding of 80 channels simultaneously in a 1RU chassis, which is actually quite significant. And then you can add this, you can add more GPUs to get more capacity in this. But as I said, I'm probably repeating myself a little bit. The big point of this is that it saves bandwidth. It generates a stream when you need it. When someone says they're on their client and all of a sudden that 1080p, their bandwidth drops for whatever reason, and your client talks back to the server, says, I need something smaller. It generates it almost instantaneously. So some of the primary use cases would be, I said, for storage. As I said, the majority of your requests are for the highest profile. So when you're generating 4 to 5, 6, sometimes 8 different profiles, it's just a waste of bandwidth and storage. So we generate that on the end. We use GPUs for this. While a lot of our transcoding is done in the CPU, we went to GPU technology because it's just simply more efficient. And we can generate a lot more streams. And it allows you to have lighter weight servers. You're not going to spend as much on your server because you've offloaded all that processing to the GPU. Like I said, the secret sauce is just being able to do it quickly. But this is really groundbreaking. It's a new product which we've just started to bring out. I'd love to talk to people on this if you have some applications for it. We've gotten a lot of interest from people like Amazon and other large providers because they see it as a huge savings for them. When you're sending out hundreds of thousands of streams at any given time, to save even 5 megabits a stream, that's a tremendous amount of bandwidth. So talk a little bit about ATSC, something I'm sure a lot of you guys are very familiar with. In 3.0, obviously some things changed from 1.0. Probably the two biggest things of it is the video codec went from MPEG-2 to HEVC, and the audio changed as well. It went to Dolby AC4, Atmos, or MPEG 3D. It's a more efficient platform. It offers broadcasters additional ways of making money, additional content in the same thing. So in our box, we produce a product that has 8 HD channels or up to 24 SD channels. And we've integrated in a lot of different functionality into that. I'm going to jump back to 1.0 for a second. Just because that is still the standard. As I think most of you are aware, when you switch over to 3.0, you still have to have a 1.0 signal going out. I believe it's 5 years. I could be wrong on that. So you do have, but you're going to be doing both systems simultaneously for several years. We can upgrade our 1.0 solutions to 3.0. Often it doesn't make sense because it requires different processors and things like that. 1.0 is still used quite a bit in low power TV, and they're seeing there's a significant amount of growth in those markets because the cost, the barriers to entry are much lower than in a full power. But within that box, there are several different components that we build in. So obviously you have your encoders and transcoders. That's going to be part of it, and a statistical multiplexer for those channels. But we build in your emergency alert system. For audio, we have a ComAct monitoring system that maintains compliance, your PSIP for your channel guide or EPG and things like that. We also have added in a logo inserter or a bug inserter that's standard in the system, as well as a text scroll. So for a large broadcaster, you're going to have all these things in master control anyhow. So you don't necessarily need them in the box. But if you're a smaller station or a low power TV station, you don't have the luxury of a large master control system. So we add that in. So basically you bring your video in and then you plug this into your exciter or a transmitter and you're done. We're also seeing in 3.0 that sometimes you're going to your modulators or transmitters through an STL link. Other people now are starting to go over the internet. So if you're going over the internet, you have to add some type of error correction to that to make sure that you have integrity of your data at the transmitter. There's various different technologies in that. SRT is one that's being used quite widely. One of the reasons is it's an open system. You're not paying large royalties. It's very efficient. A lot of people are supporting it. Zixi is a private company that has a very good solution. There's video flow. There's a lot of different ways of doing that to send it to your transmitter or to your transmitter site. And this is just another diagram that says basically saying this is just showing multiple transmitter sites going over the internet or an IP connection. In your formats in ATSC 3.0 in your system, you want to have different things. So now when we say an MPEG-2 transport stream, I do want to back up for a second. Even though we're not using an MPEG-2 video codec, the wrapper or the pipe that you're putting it in, how you're packaging the stream is an MPEG-2 transport stream. That has maintained through MPEG-4 and HEVC and will probably stay through other technologies as codecs, the next generation beyond HEVC, whatever that may be. Typically that's over an ASI output. Traditionally, now we're seeing a lot of that over IP. So it's being packaged into IP packets and sent that way. It can be single programs, it can be multiple programs in one transport stream. You can send that out. If you're sending out IP, it can be a unicast, a unitary stream going to one person, or a multicast going to multiple locations simultaneously. You also need to package it for MPEG-dash for your OTT. And then there's some other technical requirements, A324 and 331 and a bunch of other things. And we're compliant with all of those. iLux is, let me just jump into this, is what we're calling our ATSC broadcast solution. Lots of different inputs, lots of outputs, as I mentioned, has stat muxing built in. We also have a technology that's called constrained VBR. If you're looking at a MPEG stream and the way it encodes, if you have say a dark scene that has very little motion in it, it doesn't require a lot of bits to encode. So why do you want to send out 10 megabits if you don't need 10 megabits? So that's a variable bit rate, but you constrain it to a top end. A very bright scene with a lot of motion is going to require a much higher bit rate, things like that. So some of the features we have in iLux, as I mentioned, was logo insertion, emergency alert systems. We can work with virtually any input. We can work with any output that you want. We have redundancy, all the different transcoding, different audio codecs. It's all kind of built into that. This is a very similar block diagram to what I showed before. Any questions on anything that I've covered? I kind of tried to go through things reasonably quickly here because I know it's kind of late for you guys, after dinner time. Are any of you guys radio guys, by the way? Do you have radio people as well as TV people?
Yes.
Okay. We also
Yes.
have some radio solutions as well for typically going from the studio to the transmitter site. as STL links or IP links. We can do that as well. The key to a lot of this is the technology is changing. We've built over the years a portfolio of hundreds of different modules that we can build into a system to meet someone's specific requirements. And we work with you so you basically buy what you need, not what someone wants to package together. We're also very, very cost effective. I would say our ATSC 3.0 solution is somewhere around half the cost of a harmonic solution, and significantly less than a TEM and some of the other competitors out there as well. They're all good solutions. I mean, there's these days the technology that we have in encoding and transcoding. There's no one company that is, hands and feet above anybody else. Everyone's pretty much on par with quality, and it gets down to feature sets, support. We are US based as well. We do 24/7 support. We've worked with a lot of different broadcasters over the years on that. I said LPTV has been a very significant portion of our business in the last couple of years. It was a market that was underserved on that. But that's basically what I have.
When you say you have radio products for STL use,
yeah, basically,
what kind of packaging is it, and what goes over it?
Well, basically, it's based on our same server technology, where we'll bring it in and package it up and send it over the link. So we have a transmitter and a receiver that you're sending your data on. I can, if you want, shoot me an email, and I can get you the specific details on that. I joined the company just about a little over a month ago, so I'm still coming up to speed with some of the products. I apologize for that. I've just been wrapping my arms around some of the key stuff where we see, but radio is something we do. We also do audio only encoding, which is somewhat unique these days. Most people that have encoders, obviously there's audio involved in it, but they require a video stream to do audio. We can do just a pure audio encoder. There's a project I'm working on right now. It's 22 audio channels sent out to 150 locations, head ends basically. That there's, it's like your music channels, and we can do that without any issues at all. We bring it in. We don't require video, which saves you money. There used to be a lot of audio encoding out there, but that market seems to have shrunk quite a bit for whatever reason.
Jay, I have a question for you.
Sure.
How does Nielsen keep track of everything with OTT and all that?
They do have some methodology in there because they can, through watermarking, they can watermark the streams. I don't know specifically how they do that, but they do have a way of monitoring, and that's part of the analytics that we get with OTT. When you're looking at that whole system, you basically know what content went to what IP address. So you do have some record of it, of how long it was watched. So it's kind of native in it, but I may be wrong. So I think it's that Nave, I know, is some of their watermarking that they do. And then there's other systems outside of the US. But there are methods that are built into the system, because it was when these systems were designed, obviously it was designed with revenue in mind. Right. So you have to have some way of tracking your viewership, of knowing what is there, so you can get ratings. So therefore you can set your advertising rates and everything else based on your audience. But as I think as we see, as ATSC 3.0 starts coming out more and more, you're going to see the hybrid applications of it. A good example of a hybrid system, broadcast system, would be DirecTV. DirecTV, and I don't know if I had DirecTV, I don't know, I'm sure Dish does it as well, where you had your satellite connection, but you also have an IP connection. If you were watching linear broadcasting, it was coming over satellite. Most, but some was still broadcast over satellite, but most of your on-demand was over the internet. It depends on what it was, because by nature on-demand is unicasts. you may have 10,000 people looking at the same movie, but they've all started at different times, and they're stopping and starting and pausing, fast forward, rewinding. So they all have to have their own unique stream coming to their own broadcast to them. And that would be very difficult to do over satellite. You'd have to have, a satellite network 10 times larger than they have today. But they do send some stuff. They anticipate some of it, or there's they call near video on demand, where it'll be things where you can select the channel, but it's all being broadcast at the same time, and that would be a multicast. But DirecTV is a good example of a hybrid system where they've combined OTT with traditional satellite broadcast. It's not traditional over-the-air broadcast as we know from a local TV station. But it's the technology of it's where we are today, and it's just growing. With bandwidth becoming more available to people. In your home. I mean, it's not too long ago, you had 5 megabits was a big fat connection to the internet. Now, the minimum you can get from many providers is 100 megabits. And then you get fiber, getting gigabit connections, things like Fios and a lot of the cable companies and cable modem now are providing gigabit to your home. Now, I remember years ago, there was a big push. I think it was AT&T was doing a test sending DS3s. It was fiber to the home. They did 2 locations. One was somewhere in the Bay Area, and I think the other one was somewhere in Texas. They had 2 smaller cities, and they built networks where they effectively had DS3s coming into your house, and that was groundbreaking at the time. I mean, now that's average bandwidth that you can get. And even things like, I'm sorry, go ahead.
I was going to say, so how will broadcasting in ATSC3 remain viable over a long term if so much is going to be able to be done through the internet?
People still want linear broadcasting. I mean, you still want to see your local news, your local content. I mean, I personally, we had DirecTV. I have 5 televisions in my house. And it was $250 a month, which was absolutely ridiculous. We realized that there's really a dozen channels we watch on a regular basis, but I also wanted the local content. Where I particularly live in San Diego, because San Diego's lots of hills and canyons, I couldn't get OTA. I bought the highest gain antenna I could find, put it on top of a pole on top of my house, kind of gaffer taped it to the chimney and ran a piece of coax inside to a little box, and I could get exactly 2 channels. And they were opposite directions and they were ethnic broadcasting. I couldn't get any of my local channels because of where I was located. So I started looking at other things. Ended up, we have Spectrum, or it was Time Warner at the time. And they do a OTT package. I think it was called Choice. It was like $40 a month. It was as many TVs as you wanted. It was all the local channels. It gave me the stuff that my wife wanted, like MeTV and Antenna TV, so we could watch the old stuff we saw as kids. And it worked really well. And then you select, it gives you all that. It's about 40 or 50 channels. Then you can select 10 individual channels you want. And we found that was pretty good. I also have a vacation rental out in Palm Springs, where in the HOA, they have expanded cable with HBO and Showtime. So I can use that login to get all the other channels that I want. And we're on Roku sticks, and it actually works pretty well, except of course when Time Warner starts having problems with their cable modem and it chokes down or it goes out or whatever. But that can happen in anything. I mean, but linear broadcasting, I mean, the local channels are going to own linear broadcasting, and that will be the same for forever. I mean, it's carried on cable as well, but it's still anything that is live right now. Major sporting events, a Super Bowl, World Series, football games, baseball games, basketball games that are happening now. People want to watch them as they happen. It's all linear, and that's going to be broadcast. And ATSC gives you, 3 gives you the ability, a broadcaster, to have some of those auxiliary channels in there. Maybe it's a sports channel that you have for local sports. But that's just my take on it for what it's worth. So, anybody else? Anything? Any other questions or anything? I gotta say, I'm very impressed by the audience that you guys put together. You know, that's a very large group. Most of I do, you know, a fair number of these presentations, and typically it's average about 8 to 12 people. So to see 30, 40 people is quite an achievement for that.
Yeah,
And
it's
just
been working out well for us.
yeah, no, and the way you've done your presentation. I mean, you've to put it mildly, you got your shit together. Some of the other chapters, I kind of cringe.
Don't let it
But-
go to your head, Tom.
But no, I'm very impressed. And then hopefully,
We've
once
been at it for a year now, so.
yeah, once everything changes and we start coming out, I like to get out and see people, and I enjoy going out to stations and seeing the plant and seeing all the different bells and whistles. Yeah, I'm a knob dicker at heart, so I like touchy feely and seeing what's going on. Quick question: that expo that you have, is that like a little mini trade
Yes.
show?
Yes.
Send me some information on that. It might be something we want to participate in.
Okay.
I like to do
So
smaller
we canceled for
regional
this
stuff.
year, but yeah, 2022.
2022.
National will be hopefully coming to do their national fall meetings with us in 2022. So that kind of draws a bigger audience too.
I know a lot of people from the States don't
Yeah,
go to
I think
IBC,
that's-
but IBC is in September. So it's something you may want to think about. Make sure you're not at the same
Yep.
week as IBC as well. That could
Yeah, I don't know if they've announced that far out yet. We always try to stay away from the bigger shows, so we may wind up changing again.
Yeah, and NAB threw a wrench in the works this year, moving it. Well, they had to move it. There's no way
Yeah.
it would. But this year,
Yeah,
my
when they did
understanding,
that,
it's
Right.
going to be a much smaller show than it has been in the past. It's going to be the Central Hall and the
Mhm.
North Hall. They're expecting maybe 50,000 people, or they've been getting 80 to 100,000. So I think it's not, which I think is actually good. It means the people that are there really want to be there. You'll be able to spend more time
Mhm.
with people. It'll be, I think, a higher quality, better bang for your buck for the time that you spend in Las Vegas. So we'll see, but hopefully by that time we'll all be vaccinated and things will start getting back to normal.
IBC
Yep.
for 2022 is September 9th through the 13th.
Okay, so it's earlier. It's early September.
I think it's going to be a lot harder to turn the sound up when the commercials come on.
But yeah, I'm looking forward, man. Also looking at, is there a regional show in your area other than your expo? Is there like a,
No,
so you kind of, okay, so I like doing those type of shows, exhibitions,
it.
expo. Yeah, definitely send me some information on it, 'cause that's what we're looking. 'Cause I know there's a big one in Texas. There's a big one in the Midwest. I think Michigan has a big one as well. That there's all
Michigan
big,
is virtual this year.
yeah, that would make sense. Some of them have expanded now in states. Where was I just recently? I forget what, I just did one there. It was one state, now it's 3 or 4 states that are combining together.
That's the Michigan show. They're calling it Great Lakes Broadcasting,
Okay.
and it's Michigan. It's also let's see, Wisconsin, I believe. No, Maine and Connecticut.
Michigan,
So-
Maine, and Connecticut?
Yeah, a marriage made by necessity.
That's well, I guess it was virtual. The geography doesn't matter too much.
They're just trying to get the numbers up.
Yeah, I mean, that's the thing.
I'm thinking of doing it, but it looked like less than a dozen vendors had signed up. And just for the record, I'm a vendor too.
Yeah, the virtual shows, I mean, if you're looking for something specific, they can be good. I did with the company I was with previously, we did NEB New York virtually as well. Actually, oh no, we did NEB New York, and SEMTI. And I've always loved the SEMTI show. And I would say it was a disaster. I mean, there are just very few people. I mean, I guess if you were Sony or Ikegami or Grass Valley or Ross or someone like that, there's value. But beyond that, and it's just different in a virtual show. You know, someone has to specifically be looking for you versus, you know, just being there and people walking by and seeing something at your booth, and being able to engage people and just, you know, chat with people, have a beer, you know, whatever. It's so I think the allure of virtual shows has worn off quite a bit. Just my personal take on that.
Haven't gone to beer yet, but I'm getting there.
It's Miller time somewhere. Still early here in San Diego. So.
Well, thank you, Jay. Appreciate you
No.
doing the presentation for us tonight. And
I
very informative.
I appreciate the opportunity. Hopefully I gave you some good information. Maybe hopefully you picked up something from it. But feel free to contact me anytime. I mean, if you want additional
Sure.
information, you know, we're more than happy to send out to you. You know, as far as our products, it's kind of hard to do an online demo of a transcoder because there's not really much to see. But we do, you know, we can show you our user interface, which is very intuitive and things like that. The other nice thing is because we are software based, if you want a demo on something and you have a server, we can just load our software onto your server. You know, it just needs to meet some basic requirements, and we can set up, you know, give you a 30-day demo or something where you can, you know, play with it, try to break it, that sort of thing. We also have servers we can send out, so we're very open to doing that, you know, for our customers, you know, and have a dialogue. But so just bear in mind that, you know, we're not afraid of doing special things. You know, there's some feature that you want that you can't find somewhere else or something. Hey, this would be really nice to have. Let us know. You know, if it's something that's viable, you know, we'll do it. Now we can usually do it pretty quickly. We've got a really, really good engineering team.
Sounds good.
So thank you, everybody. Stay safe, stay warm.
Yep. Thanks.
You know, up where you
Thanks
guys
to
are.
everybody for coming out. And Wednesday, March 17th will be our next one. And I'll get the word out as soon as we have a presentation lined up.
Cool. Very good.
Thank you,
Stay
Jay.
safe, everybody.
All right,
Thank you.
thanks. All
And
right,
stay
bye-bye.
warm.
Thanks, guys.
Yep.
Thanks, everyone.
So long. Good to see you all.